When you are modeling a Savonius VAWT in QBlade, you will realize that you are going to get CFD, which is computational fluid dynamics, the lift and drag information for this airfoil or profile within 170 and 180 degrees, meaning that the typical area for where you have the angle of attack for the regular airfoils, you do not get any reading for a Savonius drag in QBlade. So you're able to understand when you search other literature and see that the numbers are not coming up right, that QBlade is not optimized for a drag-based vertical axis wind turbine system. Hi there and welcome to Carpenter Resources. In this video, we are going to see how QBlade performs on a drag-based vertical axis wind turbine. From then, we are going to do a model of a vertical axis wind turbine, the Savonius, in this case with a semicircular profile, and then we'll move on to another software. So once you open QBlade, the intention is to generate an airfoil, and because they are already inbuilt airfoil, you can choose to select one. But in this case, for a profile that is quite different, assuming you are doing a lift-based turbine, you can then go and import your own points. You import points in order to generate your own user-defined airfoil. So if you are working on lift-based, there are different airfoils that you can do to generate it, which is similar to the wing of an airplane. But when you want to generate an airfoil that is different, for example, that is semicircular, you need to actually generate points in probably a spreadsheet. So these are some of the points that have been generated, probably in a spreadsheet. After generating it in a spreadsheet, you then convert it to a CSV file. That CSV file is then opened in Notepad. This is an example of the file that was generated in a spreadsheet. So it was done for both a semicircle and an ellipse. So once these files are, of course, it will be separated, because all you need is the heading, the title of the airfoil, which is what you have, SAV 18003. Then the X points and the Y point running all the way down, and in this case you have from 0 to 1, so you can take whatever convention you want. So once this is done, from that CSV file it is opened in Notepad, and from Notepad it is then saved as a .dat file, a .dat file. So this is a running of the CFD using Xfoil within QBlade in order to see the results. So you can see there's no details updated regarding the drag, the lift, or even the moment of movement. You can't see any of it, and because of that, if you go to extrapolating this in a 3D space, it's not possible, because in the 2D plane it was not achievable. So in any case, you cannot do anything further with QBlade while working on a Savonius vertical axis wind turbine, because it is drag based. So we model this in another application. So this is the semicircular VAWT, Savonius VAWT, which will be used in a different program, which is actually online. It's a different application online. This is it here, a same scale that will be used to model it in terms of its CFD and FEA, that's finite element analysis, as well as the computational fluid dynamics. In the next video, it's going to be done there, and you will see the outcome of the analysis. I'll also provide instructions for viewers to also go ahead and try and get registered, because it's online, to get registered for the free version and communicate with same scale as to what they want to achieve in the design or handling vertical axis wind turbines, or using their system, their programming platform, in order to carry out some design of different profiles for vertical axis wind turbines. So you can see that QBlade is not optimized for a drag system. Thank you for watching this video. This is Catchment of Resources, where we create for better living.